Thank you, Daniela. Thank you all for giving me the opportunity to be here. It's an honor for me to be able to share part of our work at IASA in that respect. So I will talk today about the environmental co-benefits from implementing global circular municipal waste management systems to highlight the crucial role of these systems, of improving those systems in reducing greenhouse gases, air pollution, and water leakage into aquatic environments. So first, I want to acknowledge that this is not just my own work. This is work of a team, and this is also why we have quite a bit of people working behind me, and we're working together on a team on that. So before we go into the topic, I would like to tell you a bit about IASA. IASA is the International Institute for Applied Systems Analysis located in Austria, and we conduct multidisciplinary and transdisciplinary research to help policymakers to find long-term solutions to the global challenges. So we have partly sponsored by the national member countries. We have countries from Africa, Asia, Europe, and the Americas. And also just a fact about this is our main building, our Schloss. And this in the mid-1700s, so the building came into possession of the Empress Maria Teresa, and it was used as the summer house, like for summer holidays. Also, I want to notice that the IASA Charter was signed in London in October 1972, and it was an agreement between the United States and the Soviet Union, because the idea was to work together beyond just military and space matters, but go also into trying to work into the environment, health, and energy and protection of the oceans and so on. So now we can go into what is the topic about. So we will look into the waste sector, and we will look at the impacts. But it's important to look into the waste sector and what are the co-benefits that we can get of it when we improve our systems. So as we know, the waste sector also affects climate because of especially emissions of methane from landfills, but also from wastewater treatment. And we also see that there is a high potential to mitigate these emissions towards 2050, reaching about 80% of the potential reduction. But in addition to look just at the greenhouse gases, we also see that there is impacts on air pollution. And when we look at all the different air pollution sources, we see in terms of PM 2.5 emissions that waste and open burning specifically accounts for around between 10 and 15% of the PM 2.5 emitted for anthropogenic sources. We also see that through the improvement of the waste management systems, we can reduce and actually virtually eliminate the source of air pollution, and also to reduce the health impact associated with it. In addition, when we look into the waste leakage into the aquatic ecosystems, we see that around 74% millitons of municipal solid waste leaked into the aquatic environments in 2020. And if not measures are adopted, this is expected to increase 36% by 2040 compared to the baseline. We also see that the leakage into rivers accounts for 91% of the total leakage found in aquatic environments. And in addition, we see that most of the leakage is generated in urban settings. But in addition to the environmental aspects, we also see health impacts related to waste and management of waste, actually. And we see that we have exposure to chemicals and particles during waste collection, transportation, and also ecosystem damages, and also resource depletion when we don't take into account the recycling of the reuse of materials. And what this graph is showing us is the mortality rate related to the PM 2.5 exposure in the different regions around the world. So looking into that, then one of the co-benefits of the waste management is, of course, the reduction of short-lived climate pollutants, which are pollutants that have a stronger warming potential in the near term compared to the CO2, and therefore it's important to tackle these short-lived climate pollutants, specifically from waste, methane, and black carbon, but there are some others as well. And in addition, specifically with methane, we see comparing, for example, what is now taken or revealed by the remote sensing or satellite images, we see that even in well-managed landfill sites, we are experiencing emissions or leakage of methane. And this means that probably there is an underestimation in the bottom-up inventories related to the emissions from dump sites and landfills. And this is something that we are trying to work on, and not just our institute, but in general the community, on improving these bottom-up inventories, but also trying to understand where are these opportunities in terms of technological development to avoid this leakage. But in addition to air pollution and greenhouse gases, it's also important to look at why is this important in terms of aquatic environments. And in that sense, we see that waste leakage is a major concern because it's affecting the aquatic environment and human health. And as I mentioned before, land-based waste has been identified as one of the highest or biggest sources of marine litter. And actually, currently, the discussions are more related to the plastic leakage and not to the general municipal solid waste. But we also have to take into account that high organics in, for example, food waste or untreated wastewater from the domestic sources, they are also problematic for our water courses, for example, for eutrophication and so on. So it's important not just to focus on plastic, but also look more in a systematic way how we can solve the waste issue. And regarding that, we also see that currently, of course, we have many different kind of plans or regulations tackling waste, and also specifically plastic waste, like the Basel Convention. We have the Sustainable Development Goals, and now we all have all this circular economy framework and setting in which we are trying to look at and trying to adopt this on a different kind of levels depending on the level of development of the regions. And this, of course, has led to the negotiations now that we know about the plastic treaty to try to reduce the plastic pollution in aquatic environments specifically, but also this has some other impacts on other air pollution as well, and so on. So what I will present now is 2 studies related to waste management. And this slide is really important to try to understand all the results of what I'm going to present. So for this, I'm using the greenhouse gas and air pollution interactions and synergy gains model. It's a model that is developed at IASA, and it's an integrated assessment model that evaluates the greenhouse gases and air pollutants from all socioeconomic sectors. And it integrates 2,000 measures to co-control air pollutants and greenhouse gases. It estimates emissions, cost, and it has an atmospheric dispersion model to evaluate the health impacts, but also ecosystems impacts. And then through the optimization, we can develop policy targets for that. And this is the main kind of method used to estimate the emissions and what we will see in the next slide. And then we created some different scenarios to evaluate what are the mitigation potentials of improving the waste management systems. And I don't know if you are familiar with the shared socioeconomic pathways. These are pathways of future possible developments that look into 5 different kind of potential developments in terms of socioeconomic drivers, but it also looks into what are the challenges for adaptation and mitigation. And for example, when we look in this case, if we look here at the SSP1, but if we look at the SSP1, this means that it's a society in which the environmental actions are really important, are taken into account. There is not inequality within and between regions. And of course, the challenges for mitigation and adaptation are lower. In contrast, if we look, for example, at the SSP3, So we see that there is, of course, an unequal society in which you have fragmentation, in which there is not possibilities to work for the environment because there are other kind of needs. And if we look to the 5, for example, it's a fossil fuel kind of development world in which consumption plays a significant role, in which you don't have any strategies to reduce waste generation and so on. So for each of those, we developed what we call baseline or current legislation scenario and MFR scenario. And this is something that we see here down. So we developed for each of those 2 sets of scenarios according to the different narratives describing the potential futures. And we develop also what it will be the maximum feasible technical reduction potential in each of those scenarios. And what is the meaning of that? How the different type of worlds could adopt the circular municipal waste management systems. And these include restrained landfill of municipal solid waste, increased recycling rates of materials, inorganics and organics, and additionally, the SSP1 integrates in the mitigation scenario the SDG goal related to the reduction of food and plastic waste by 2030. The idea of the scenarios is that they will reach the adoption of the mitigation strategy all 100% by 2050, but the difference within them is how difficult for the different countries it's going to be to be there, depending on the socioeconomic development. In that sense, this study actually was published in 2022, and then uses the 2020 as a base year. So this is already we are updating all the data sets and so on. And what we see, for example, is that in 2020, the world generated around 2,500 teragrams per year of municipal solid waste. And this is expected to increase to around 4,000 teragrams per year in 2050. However, when we look, for example, at the fossil fuel scenario, we see that the increase is still, of course, completely higher because this is a scenario in which consumption plays a significant role. In addition, when we implement the strategy of reducing municipal solid waste generation in terms of food and plastic waste, we still see that there is a possibility to reduce the municipal solid waste generation, but this is not going enough. It's not going to be enough to bend the curve, and this is because it's driven by population growth. Also, we see that, as we already probably know, the municipal solid waste per capita is higher in urban areas compared to rural areas, and that's why now we have all these assessments related what to do in cities, not just in terms of waste management, but urban planning and reduction of energy consumption and so on. So here, the study showed, for example, that of course, when you see there the graph, you see that, for example, Africa, because of the population, China and so on, there are the regions that generate most of the waste in terms of quantity and absolute numbers. However, when we look at the generation per capita, we still see that Europe, North America, they generate most of the waste per capita, even though the population is lower. And this is, of course, even though those regions have better waste management system, is still not appropriate, or they are not looking into the reduction or strategies that aim to reduce the consumption and reduce the waste generation. When we look now in terms of the global municipal solid waste management, we see, of course, that the world has, in average, taken anaerobic digestion and composting compared to past years as well. But we also see that most of the waste is still unmanaged. So it's still probably ending up in dump sites, a higher fraction is uncollected still. So that's why you have that scattered waste with potential to reach water courses, but also you have open burning of waste, and then you have all the problematics related to air pollution. And we also see on the other graph the methane emissions, and these are the methane emissions estimated like in 2020, around 30 million tons per year in 2020, and under the current conditions of under the current legislation, these are gonna continue, of course, increasing by 2050 if not action is taken. So this is now we are gonna look into more kind of regional level. And this is important to show, for example, in Africa, if we see the first column there. So we see that we have quite a bit of emissions from unmanaged waste, and this is, we all know that. But what is interesting here also is to look at the EU27 plus the UK, because we see how the evolution of the legislation and the implementation of that legislation have resulted into the decrease or reduction of methane from the solid waste sector. So this is important to notice that when you have the appropriate means to implement, of course, regulations, they also have an impact. This is an instrument that is needed. So we need to have those regulations to be able to reduce also methane emissions. Of course, we know the problematic about the implementation, but it is possible. It's not something that will happen in 5 years or so. It takes time. For the EU also took time, but it's something that it will work. And also in contrast, if we look at North America, we see that their waste management systems are mostly based on landfills. They have landfills with gas recovery mostly for energy use, but also flaring. And then you see also the related emissions. We also see that now the North America region that includes the US and Canada, they are also now starting to work on the diversion of waste from landfills, and then you can see an increase of waste ending up in recycling, but also starting to go into anaerobic digestion and a bit of composting. This is something that we can see recently, starting from 2015 already. So here, what I want to show is what happened with the emissions for the different kind of scenarios, but also for the different regions. Sorry, this is the EU27 plus the UK. I didn't update that graph. But then what you see and what I wanted to show here is the difference within the regions and between urban and rural areas. For example, again, if we look at the EU has good policy and has implemented the policy in which you see reductions of methane, but also, for example, bad carbon. But in other regions, like if you look at Africa, India, Southeast Asia, you will see that even under all the different scenarios, this, on the baseline, this is projected to increase emissions. And this also shows here that it's important to take measures also because they host a big part of the population, but also because more than the climate is also a health problem. It's air pollution, air quality, and therefore they have a higher mortality, let's say, compared to the other regions. And what I wanted to show, not to go that much into detail into all the different scenarios because it can be a bit confusing, I will show the comparison of 2 of them. We will look at here at the SSP1, which is related to the sustainability scenario, compared to the SSP2, that is the representation of what we have now, which is the business as usual. And in that sense, we see that the SSP1 is able to reduce or could abate 85%, 90% of methane emissions by 2050 with the existing technology. It's not necessary to develop any further technology because the technology is there. But also, if we want to reach and to get like to this target or to this level of reduction, we actually need to adopt the reduction of food waste generation. That's something that is not just the diversion, but also the reduction. And this means that the solution is important not to think that they're as an independent, but also it's important to look at them simultaneous actions that need to be taken. And also this scenario shows the importance to look into the prioritization of strategies targeting at the reduction of food waste. When we want to compare this on what will be for the waste sector regarding the target of the global methane pledge, we see that if we want to achieve 30% reduction target, we will need to have emissions equivalent to 21 millitons of methane. And this means that we will have to reduce our methane emissions by 84 million tons CO2 equivalent per year between 2023 and 2030. However, we need that even in an ideal world in which we don't have inequality, in which we have everything that we have, the technological development, the support, and so on, this is not going to happen by 2030. So the world is not going to be able to reach the methane pledge. And it's also that we see now. And also if we look at the SSP2, we see that we are still increasing, even with the kind of efforts that are happening here and there and the small efforts. The methane emissions are increasing, and we are probably not able to meet not this global methane pledge, nor the future that they are working on new targets for the 2035 and potentials for 2050. But also, if we look into the PM 2.5 emissions, we see, of course, that the increase in collection of waste can help, and this is something that we were discussing this morning in our meeting, can help. Actually, it's a very important approach to reduce emissions from PM 2.5. The situation there with the just increasing collection is not enough to do that. You need to also improve the management. And also because there are studies showing that when you increase collection in urban areas and you don't have the proper management, in transfer stations, people burn the waste because they cannot deal with it. And also, of course, this happens on the dump sites. The people, and then so collection is an important part of it, but it also needs to be worked together with other kind of measures. And of course, if we continue as we are now, of course, we see here, we will be able, there are some countries already adopting targets to reduce the open burning, but still it's not going to be enough if it's not done like in a quicker manner. But what is the meaning of this for climate, which is what we are thinking about? And in that sense, in 2023, Chuang tried to estimate what is the budget that the municipal solid waste sector has if we want to meet the 1.5-degree target. And in that sense, they estimated, or the study estimated, that on the business as usual scenario, the municipal solid waste system at that global level is projected to exceed the 1.5-degree target between 2028 and 2029, and the 2 between 2028 and 2043. So, but what happens if we just look into retrofitting landfills? So if we just look into strategies to improve landfills, to close dump sites, to recover the gas, this means that it will be possible to reduce the emissions, but they will still remain at the 2-degree limit level, which is not enough for the climate. But in addition, if we adopt the composting strategy, we can already see that to meet the 2 target is plausible. So if we are just adopting the composting, but when we adopt the circular waste management systems, it will be possible to prevent the overshooting of the temperature limits, and then we will be able to comply with the 1.5-degree limit. And I think that's what is highlighted here is that one strategy will not save the municipal solid waste sector. This will not work. This will not happen. This, in terms of climate, we need to look systematically into the collection, into the improvement of landfills, into the improvement of data as well, because without data, we don't know what to do with all the waste we have around. And also to keep in mind, and something that we also talked this morning, is that the waste sector, the management is a right of the people. And it's not just because of the sake of climate. It's actually a right that prevents people from illnesses, prevents people from and helps people for their well-being, improves their well-being, and that's really important. But now that we saw what is important for climate and air pollution, now we are going, and what about the aquatic environment? So in that sense, we extended this study to look into the aquatic environment because we wanted to quantify and identify what are the hotspots of municipal solid waste leakage in rivers, lakes, and coastal areas. And the message, or what we wanted to extend the study, is because we wanted to understand what are the regions more affected by the leakage, where are the hotspots. Rolls also reiterated that the problem needs to be tackled as a system, because when you are thinking in climate, air pollution, or aquatic environments, and so on, one strategy can be beneficial for all of them, to reduce all of them. So it's not always fighting the air pollution community for air pollution, the water we are all fighting for the same banana, let's say. And that's the reality. We have to join forces. And this is something that we have also, not just us into the Institute, but all people working on waste is working on and demonstrating on that. So how we did, we combined all the spatial data sets, or all the data we collected, and improved our data. Also, we used the same results we had in terms of waste generation and so on. We introduced the circular economy strategy, and we combined this with the different kind of spatial information on river, basins, lakes, and coastal areas. And what we find is the same. So this is related to the municipal solid waste generation. We see the composition of the waste, but we also see, we were focused on here on what happened with the scatter waste. So the part that is uncollected, but is not openly burned, but it stays on the areas. And we see that the scatter waste accounts around for the 14% of the total municipal solid waste generated. And we see that most of it is generated in urban areas. We see that from the scatter waste, 87% is of the total scatter waste. So 30% of the 87% is generated in China, around in Southeast Asia, 20%, India, 17%, and Africa, 20%. These are the regions that have, and this is, of course, not surprisingly, because these are the ones with higher population, higher quantities of municipal solid waste, and low management systems. So in our study, we estimate that the total global potential of municipal solid waste reaching rivers in 2020 is 74 million tons, which is around about 21% of the global estimated scatter waste, and 3% of the total generation in 2020. We see that the potential rivers receiving the highest quantity is the Yangtze River in China, the Yellow River also in China, the Nile River, the Brahmaputra, and the Shuyan. These are the 5, but we have a list with like the 10 or 20, I don't remember anymore. In terms of the potential, because we were also looking not just at rivers, but also lakes and coastal areas, and our assessment indicates that 1.35 million tons of municipal solid waste enter lakes in 2020. Lake Victoria is one of the most polluted, and 79 million tons enter near coastal lines, enter the seas. So here I will just show a comparison of the different kind of mitigation, the results of what happened if we adopt all the circular strategies, what happened with the rivers at the different kind of years, and this is in 2030. In the upper one, we see the sustainability scenario, and in the down part, we see the regional riverine. And what we see here, for example, is if we zoom into this, in the South America, we see that when you have faster action, so you see, for example, the basin of the Amazon River and the basin of the Plata River, which is that one, it can improve quite a bit. So they can actually reduce the input of the waste into the rivers, which is going to be more difficult if you have a world in which they are not talking to each other, in which regions are not supporting each other. But we also, when we look, for example, at Africa, so we see that this, even in the SSP1 is going to be challenging. So you still have rivers receiving quite a bit of municipal solid waste leakage. But we also see some improvements, especially here in the southern part of Africa. And we see some improvements also in India. This doesn't work properly. Some in India as well. In addition, something that is important to see here is that the dark blue here highlights the 10 key areas at higher risk of receiving waste if we don't do anything else. And in that sense, we have in China, the Yangtze and the Yellow Basin. We have also the basin of the Ganges, the Nile, we have the Niger Basin and the Plata Basin. So these are the most affected basins, river basins, receiving leakage. And what I want to say here is, of course, that leakage of municipal solid waste, it depends also on population size, on the population living closer to the river or to the basin. Also, the physical environment has, of course, plays a significant role. Also, the precipitation, wind, and so on. And also, depending on the composition and the level, of course, of collection, of waste collection. But we also see that the activities related, for example, of that these communities do in terms of collecting the waste from the seas and all these initiatives, that's important, but we cannot keep doing that for the rest of the life. We need actually to avoid to have to collect the waste and so on. And in that sense, the adoption of waste management systems plays a significant role to reduce the leakage. It can reduce 80% of the waste in the aquatic environments. And this is most of the waste. Of course, you will still have the pollution from the water systems, wastewater systems, but that's a different topic. So I am not covering that today. And then we have, of course, that we also need to take measures to decouple the municipal solid waste generation from GDP growth. And also, as I mentioned before, leakage into rivers accounts for 91% of the total municipal solid waste reaching aquatic environments. And the challenge is mostly in urban areas. And this is not just having impact like in the aquatic life and so on, but also when we have floods and there is a problem with the waste because it is blocking the drainages. And this is becoming also a big problem on those cities. And also, as we saw, China, South Asia, Africa, and India account for the majority of the leakage. So for 70%, so of course, these regions, if we tackle those regions, it will be significant to reduce the aquatic pollution related to solid waste. And in addition, and this is always that I always think and that always know about that we need to improve the information related to data. But that we don't have enough data, of the uncertainty is high, it doesn't mean that we don't have to act with the information or knowledge that we have. And this was the topic related to this. And I don't know if I have a couple of minutes to show something else, but it's a completely different stuff. And this is, I wanted to show this because of the institute that invited me. So we are part of a consortium that supports the European Commission on reaching the Green Deal. And in that sense, we are modeling the non-CO2 greenhouse gases for them. And within all this modeling framework from all the sectors, and modeling the wastewater system as well, in addition to the solid waste. And what I wanted to show here is what we see, what is happening currently in terms of wastewater management in the EU. So we see that the EU applies quite a lot of aerobic treatment, but now regarding the new regulation For the wastewater, for the urban wastewater, they now have to think about the circularity of the resources, and they need to start implementing anaerobic treatment because they need to recover energy. And this is something that is already on the table, that is already on the legislation. So we are assessing also the potential of how much then the combination of anaerobic aerobic treatment should go. And we did a study taking into account the vintage of the wastewater treatment plants in Europe. And it shows that there are many that they're gonna be renewed soon because they have already met the 30 years plus lifetime. And then for them, it will be like a zero cost investment because this is already planned. We also see in terms of mitigation potential that still in terms of methane emissions from wastewater, it will be possible to reduce 80% of the methane generated by these systems. And that's something that we work with them. Like we have been doing that from 2007. So for all the different kind of regulations and so on. And this is what I wanted to show. And I think that is from my side for this presentation. So thank you very much. And I think I allowed time for discussion because that was the idea as well. So thank you.